S1 Summarising Data, Example 9, Part C. I wanted to do this example separately because it's involving interpolation, and it's really important to get clear in your head when you use interpolation and when you don't. We're using interpolation because we've got group data, and you'll see it's one of those examples where there's gaps between the intervals. So I'm going to go through first of all and put on what the boundaries are, because that will help us later on. So if you think that's 31 and 32, so halfway in between will be 31 and a half. If you're going a half out that way, you go a half out that way, so it's 29.5. This would be 33.5. That would be 33.5 as well. 36.5, 36.5, and 39.5. And by now, if you've studied all the examples, you'll probably be able to guess that this is a cumulative frequency column. So I'll fill that in as well, and then we're ready to do all our calculations. So I think that adds up to 70. So n is 70 because that's the bottom entry in the cumulative frequency column. So we're looking at the length of time to nearest minute spent on the internet each evening by a group of students. Quite closely grouped together, this data. So we need to find the interquartile range. That was the point of all the questions in example 9. Start as we usually do, n over 4, which is 70 over 4, 17.5. But remember, when it's group data, we're interpolating, so you don't round. So we look for where the 17.5 value would be. Well, you've got 2 items in the first interval, and then by the end of the second interval, you've got 27 values. So we know it must be somewhere in that second interval. So let's write on the class boundaries. We've got 31.5 and 33.5 as our class boundaries. And at the beginning, we had 2 as our cumulative frequency at the start of that interval. And by the end of that interval, we've got a cumulative frequency of 27. We're after values 17.5. It's going to be roughly in the middle. It doesn't matter, it's only a rough diagram to help us visualize what's going on. So we need to work out how far into this interval this line is. And if you remember, we've got that formula. So we start with the lower boundary, which in this case is 31.5, and we add on the frequency that we want. Now this is the frequency we want. We want 15.5 values out of, how many values were there in that interval? Well, there were 25. You can see that from here, or you can actually just look at the table. There's 25. And we multiply that by the class width. Well, the class width is from 31.5 to 33.5, so that's 2. Remember, we work this part out first, then we add on the lower boundary. As an exact fraction, because I'm going to use them later to subtract, I think that's 1637 over 50. And you could write it as a decimal, but if you do, make sure you keep the full value because we need to subtract later. Let's have a look at Q3. 3n over 4, so that's 3 70s. Whoops, 3 70s divided by 4, and that works out to be 52.5. So again, we don't round because it's interpolation. Looking up at the top, we've got 27 up to the end of this interval and 57 up to the end of the next interval. So that means it must be in this interval, the third one down. And again, I find it helpful to draw a picture. So it's between 33.5 and 36.5. At the beginning of that interval, we had a cumulative frequency of 27. By the end, we have a cumulative frequency of 57. And I want value 52.5. So it's pretty near the end, so I've drawn it over towards this side. Okay. So, same thing as usual. Do the calculations. It's the lower boundary, which is 33.5, plus the frequency we want. Now that's from 27 up to 52.5. So that works out to be, if you subtract those, that's 25.5. That's how many we want. How many were there in the interval? Well, there were 30 values in the interval. And we times by the class width. Now in this case, the class width is 3. Again, work that section out first, then add on the lower boundary. And again, I did it as an exact fraction because I knew I was going to be subtracting them. So the interquartile range then is the upper quartile, Q3, minus the lower quartile. Got these as fractions. And if you type that into your calculator, we can now turn it into a decimal because we're just rounding off at the end. It works out to be 3.31 to 3 significant figures. And again, that interquartile range doesn't tell us much on its own, but if we were to compare it with another set of data, we'd make sure that we could see which one was biggest and which one was smallest. And that's the purpose of calculating it.